This is a homework help video for Chapter 5 of Statistics on the Poisson distribution. So this Poisson is pronounced Poisson. Poisson probability distribution. It's used to compute the probability of events that occur over an interval in time or region in space. For example, if you want the probability that so many traffic events would occur over some weekend, or that you would have so many defects in a section of manufactured material, that's what you're looking for. And you need to start off by knowing the average over that time period, or average over that section. And the average is written with the Greek lambda. Oh, didn't have the marker, sorry. It's that Greek lambda right here. Lambda. Okay. You need to find that out. If you don't have it, it has to be given to you in the problem, although it might be given to you in the wrong units. For example, if you needed to figure out the number of traffic accidents in a weekend, let's say over 3 days, over a 3-day weekend, let's do something simpler. Say you need to find out the number of traffic accidents, the probability of accidents over a particular day, so over one day, and you knew the total number of accidents in a year. Say there were 365,000 accidents in a year. You'd have to divide by 365 to find out that there were 1,000 accidents every day. Okay, so you would need it per day. It has to be in the units that you're working in. But that is the number that you need to do the distribution. And again, this is just a formula class, so there's the formula right there. There's also a table in the back of the book. I think it's table C, in Appendix C. I thought the formula was pretty easy. I just use the formula most of the time. So here's how you use the formula. You know lambda. Then e to the minus lambda is the first term, and that's the average that you were given. X are the number that you want to investigate. So this is the probability that X number of events will occur, given that this is the average number. So if e to the lambda multiply that. That's multiplied by lambda raised to the x, and divide by x factorial. For example, if you want to know the probability of 600 traffic accidents when the average number was 1,000 per day, what's the probability that there's going to be 600 accidents today if the average number of accidents in a day is 1,000? The x is the probability you're investigating, lambda is the average. So you just plug this in, it'd be e to the minus 1,000 times 1,000 raised to the 600 divided by 600 factorial, something that would require a calculator. So here's a homework problem, or something similar to the homework problem. You're given this information, that an average of 16 babies are born each 8-hour shift in this hospital. So what's the probability that 12 babies will be born? Now the trick here is in the next hour. If it was in the next shift, you would say the average is 16. But since you're saying what's the probability we'll get 12 babies in the next hour, you have to have the number per hour. So the lambda for this problem has to be per hour. So at 16 in an 8-hour shift, the lambda is 2 babies per hour. And that's what you would use in the problem. So this is the probability that 12 babies will be born, given that the average is 2 in a Poisson distribution. So it's e to the minus 2 to the 12th, divided by 12 factorial. And that's easy enough to work on a calculator. The next question is, what's the probability that no babies will be born in the next hour? It's not 0, and you can plug into the formula and find out what it is. You want x to be 0, given that the average is 2. This is e to the minus 2 times 2 raised to the 0 power over 0 factorial. Remember, 0 factorial is 1. I'll leave e to the minus 2 like this. You can calculate that easy enough. What's anything raised to the 0 power? It is also 1. So you see you have a non-zero probability that there will be 0 babies born in the next hour, given that the average is 2 per hour. The last problem in the homework is taken from the text. And in there they start the problem for you, and and then they leave you some blanks to fill in. And so that's what you can do, is fill in the blanks. But you can go to the book and see exactly how it's worked out. And they did the case of 3. So the idea was that they took London to see if bombs that were being thrown at it were due to some big guidance system, some good guidance system, or whether they just randomly hit London in these different spots. They couldn't tell. So they took London and divided it up into 576 regions. And now they have the number of hits. 229 of those regions didn't get hit at all. 211 of these regions got just 1 bomb landing in them, etc. One region got a total of 5 landing in them. So the idea is to create this, solve the problem like it's a Poisson probability distribution. I'll show you how to do that. And then figure out the possibilities or the probabilities for 0, 1, 2, 3, or 5 hits. And multiply them by the total number of regions. And actually, here are the numbers. I gave you the answers here, but I want you to calculate them. The idea is that it agrees very closely. Here is the number of regions you expect to have gotten this number of hits. By the distribution, you expected 227 regions to get no hits. Well, 229 actually got no hits. You expected a little over 211 to get 1 hit. Well, 211 did get 1 hit. Came up with 97.9 for 2 hits. It was 93. You see how close it was, and by this they determined that there was no guidance system. It was just total probability. That's a very interesting problem. So here's how you do it. If you want a Poisson distribution, you need to calculate an average. So first was to add up all these number of regions, and you get the total number of regions, which is 576. So this came up to a total of 576. Then you have to couldn't write that on. I'll do it in the next page too. Now you have to calculate how many bombs were thrown at it. Well, there was 1 bomb thrown at 211. That accounted for 211 bombs. 2 times 93, that's 186 bombs there. 3 times 35, like that. And so you add up all those numbers, and you end up with a total of 535. Then you calculate the average. That gives you your lambda. So here I've already written it out for you, but I want you to go through and work on it yourself. What's the total number of bombs? Well, again, 0 got 292 bombs. 0 bombs fell in 292 regions, so that's 0 bombs. And you just multiplied those numbers and added it up and came up with 535 bombs were thrown with their studying. What is the average? Okay, easy enough. You take 535 and you divide by 576 regions. This is an average of 0.2988 bombs per region, and that's the number that you want. There's your lambda for the problem. So for each distribution, you put the number of hits. For example, in this case here, you want 3 hits, given that the average is 0.9288. Now this you use a calculator because there's nothing in the back of the book. Can't do this for you, but it's easy enough. So it's e to the minus 0.2988, just following this formula right here. It's going to be divided by 3 factorial, and the other term is the lambda, which is 0.2988 raised to the 3rd power. That comes out with 0.05275. Okay, now I've got that number. I take that number and multiply it, so it's 0.05275, and I multiply that by the total number of regions, 576, and I got the 30.4. And you repeat it for all of those. That one row is not filled in the actual homework. I just filled it in here. You can use that to compare your answers. So the idea was that you find the total number of bombs and divide by the total number of regions, and that gave you 0.92 or 0.93 bombs per region. That's your lambda for the distribution. Then you go through and you find the probability for every number of hits. Let me erase this for a second. So you would find the probability for 0 hits. And then this is the 0.92 or 9, whatever you use, 0.93 is good enough. Use the formula and find that. Then you'll get an answer from there. You take that answer and you multiply that by the number of regions, and this tells you the number of regions you expected to have only 0 hits. Then you go back and do the same thing for 1 and the others. Numbers 3 is done, of course. 1.23, let's say. You find this by using the formula right here. Plug into that formula and you get an answer. You take that answer and you multiply that by the total number of regions, and that will give you the number of regions you expected to get hit once by these bombs.